All right, welcome back. Let's get ready to start the density lab. There'll be, at the end, we'll be working through all of the measurements for this sheet. You'll be getting block color for 3 blocks, length, width, and height, and the mass, and then calculating volume and calculating density. And then on the back, you'll be doing the same thing, except we'll be using Archimedes' principle to calculate the volume of a marble, and we'll take its mass, and then you'll be able to calculate the density of said marble there. But before we do that, let's have a quick talk about density. You remember that density is a physical property of a substance, and it's how much stuff there is in a given amount of space. We say stuff per space, per implying that there's a ratio. The more stuff, the more space. The more space, the more stuff. It doesn't change. That ratio never changes. You'll also see that we utilize milliliters, but we also utilize centimeters cubed. These are interchangeable. 1 cubic centimeter is a milliliter of volume. So the easy one, the one that we're going to do first, the one that involves these blocks right here, okay, is a calculation of, we can put the mass on a balance, get that, and density being mass per volume, mass divided by volume, we need the volume of this. And any sort of a nice geometric shape like this works out well, because what we can do is we can take the 3 dimensions of it, the length, width, and height, multiply those all together, and we end up with the volume. So that's the pretty straightforward one. The one that is not so straightforward is the irregularly shaped objects. And we can still do math the same way, but we end up with a problem of not being able to do a calculation to figure out what the volume is. Today we're going to use marbles. They're round. There are math equations and measurements we could take to do that. The problem for us is we don't have tools that are going to measure that precisely enough to be able to get a good measurement. So instead, there's a guy named Archimedes. He has a principle. That principle is based on the fact that when you take a known amount of water and you submerge an object fully inside of it, the displacement by the object is equivalent to the volume of the object. So if I have 10 milliliters of water and I put something under that water and the volume of the water increases to 13 milliliters, the object that I put in must have a 3 milliliter volume. So we'll be using Archimedes for our round objects today. Now on the back of this sheet, we have a couple of practice problems. I'm gonna work the first one. I'm gonna show you all the work the way that we normally would. I'm gonna let you do the second one, and then you'll be able to take that and go into the next video, which will have all of the measurements so that you can do the density, how dense is that lab, okay? So on our first piece to this, we have the solid cube of a volume 36 milliliters and a mass of 24 grams. So we want to know, what is the density? So our first step is always figuring out our knowns and our unknowns. So we know that D equals M over V. So I'm looking for density, I'm looking for mass, I'm looking for volume. We know that the density was our question mark down here. And our mass, always in grams on this, is 24 grams. Our volume is 36 milliliters. So now I'm going to go and I'm going to look, and I'm going to say my original equation was D equals M over V. Oh, I don't even have to change that. Now down here, when they want to know volume, I'm going to have to rearrange that equation and manipulate it to be V equals something. But for now, I can just use my base equation. So I'm going to insert my 24 grams. I'm going to insert my 36 milliliters. And when I do that math, I'm going to get 0.666666666666. It goes on and on and on. So some of you may be tempted to either write this answer or write this answer, to which I would tell anybody that wants to write this way, you're wrong. So please don't ever do that again. Let me tell you why. These two numbers imply a precision to infinity. We don't have the ability to go to infinity with any of our measurements. So we can't have that in our calculations either. So this tells me that I know this out to forever. This is the exact same thing as this. So these don't work. Those are not our answers. We need to go and round this. So something like 0.667 grams per milliliter. I am not going to focus on significant figures in your calculations right now. I want to worry about the process that we're going through. We can worry about significant figures at another time. For right now, I want to worry about that. So knowing this process, we're always looking for 5 things in our math. Knowns and unknowns is 1. The equation is 2. The work is 3. The answer is 4. And of course, the answer is absolutely meaningless without a unit on it. So make sure that unit is there, okay? So now again, over here, you're gonna be solving, but you're gonna be solving for volume. And then down here, you're gonna be solving for density. This is gonna walk you through that. Think about the fact that I told you in the lab, you're gonna be doing marbles. You're gonna use marbles to figure out their density. This is leading you there, okay? So work those 2 practice problems, and then when you're ready, open up this sheet, head into the video, and I will see you next time we have class. Hope everybody stays safe out there. Have a good night.